Okay, good evening and Assalamualaikum. Okay, today we will continue to topic one, and as well I have uploaded the topic two in your notes in your LMS. Please have a look at it. But that one, if I'm not sure whether we are able to cover today. Otherwise, we will just continue next week. Today we'll finish off the topic one and move a little bit on topic two, perhaps. And then the other thing is I've updated your assignment, individual assignment, and then there is a quiz in topic one. You can see the topic one, there is a quiz that you have to submit. Anyway, I'll keep on reminding you what you are supposed to do. We have 10% marks for your quiz for this course. And then the first quiz, which is in topic one, is 5 marks. And then later on, we have another quiz at the end. And then your assignment, I put up your individual assignment. And then, as I mentioned to you, I've explained the group assignment, but the group assignment I will put up, I think later, put up. But it is about the dashboard where you have to select a company and do a dashboard. But I will build a rubric on what you're supposed to do in the dashboard. But anyway, it will be about the KPI of the company that you're going to build the dashboard on. Okay, we'll continue. Now it's 8 o'clock, so we will continue. And then in the meantime, please write your name and matrix number in the chat for record purposes. Okay, okay, now I will start. I've uploaded the notes and then the recording for last week. So no, previous week, the first class, is already uploaded. Okay, and then today we'll cover about the big data. We'll talk about big data. There are many definitions that you can find big data, but we'll pick up the right definition for big data. A lot of people talk about big data, but they don't know what is big data, and then they put up their own explanation. Okay, big data. Let me share you the slide. Documents. So I have to upload this. Okay, topic one. Okay. Okay. This. Okay, we'll cover big data. Okay, we'll continue from where we left previous class. Is on big data. So there are some other definitions that lay people put up on big data. So I'd like to remind you, whenever you put a definition on academic topics, a professional definition will be using a stipulated definition. You don't use lexical definition. Lexical definitions are definitions that you use based on dictionary. So if you take a lexical definition of big data, it will means a data which is big. Big means the adjective and data is the noun. And then big data means the data which is big. But that is not the right definition. The stipulated definition of big data is what was coined by Doc Lenny when he was with Gartner. He's now, I think, still with Gartner. So he coined the term big data to refer to large amount of data. We call it voluminous data, volume. Data with velocity, because data are coming very fast. And then, so we need to attend to this data, because, and then data with variety, meaning that data with many different forms, and then structure and so on. So because we have data which is in form of video, in form of audio, in form of graphics, text, and also structured data, unstructured data, and many types of data. So that is variety of data. And then, but IBM added veracity of data, which refers to the accuracy of data. So big data, at least you have these 5 components or 4 components of big data, which is volume, velocity, variety, and veracity, but there are many V's that come on later, variability, and so on. So big data is as any set of data that is too large, too complex to be handled by standard data processing techniques and typical desktop software. IBM actually coined the term veracity, but before that, Doug Lenny of Gartner coined the term big data refers to the data with volume, data with velocity, data with variety, and IBM with data with veracity. Yeah. So, and then these are data, what it means by big data, data which is very huge, voluminous data from terabyte to exabyte. And then data come in motion, velocity to data, streaming data. Today we have something like Apache Spark that we can do stream data analytics. And then data come in many form, structured data, text, multimedia. We have looked into the structure of data before this. And then veracity, which is data uncertainty of data. So we look into accuracy of data. Data need to be consistent, data need to be complete, and remove ambiguity of data and latency, deception, and model approximations of data. So that is the situation of data. So with such with such situation of big data, it need to be handled specially, meaning a specific method how to handle big data. So volume refers to data which is big, voluminous, so we are able to collect more of it. And then when we talk about big data, we are not referring to sample data. We're not referring to sample data. When we talk about big data, we are referring to um, population data. It's about population data. And at the same time, and then uh, why do we, before we move into this big data, why do we sample data? Why do we sample data? It's not big data, but why do we do sampling of data? Anybody can respond? Nasria or Sondo Zayan?
Yes, Prof,
Okay.
to analyze,
Yeah.
yeah, to analyze the information that we have so we can take the decision or we can save problem.
Why do we sample the data?
To make it easy for us to take the decision.
Okay, we sample the data because the data is too big, so we don't want to collect our data because it's difficulty of us to collect the data, all data, so we make a sample of data. So when you talk about big data, we are not sampling the data because we are able to collect all the data. So it will be voluminous data, very huge data, because we are not sampling the data. So we collect all the data. So that's why we are looking into velocity, because these data are coming very fast, because is a real-time capture and analysis of data. So it is a unique challenge because we have to collect all this data. So we don't do sampling. Yeah, so when it refer to big data, it's not about if somebody tell you that you do sampling of big data. No, big data, if it means the big data, it doesn't sample. You don't sample because data is voluminous. Data is coming very fast, and you do real-time capture of this data. And then data are there are various format of data. So you can have text data, audio data. So it's very complicated, but you take all. Whereas, so that's why what we refer by variety of data. So analyzing this data, you need to have non-traditional method because of the voluminous, because of the variety, because of validity of data. In the same time, you involve so much of uncertainty in data. So inconsistency, lack of reliability, and biasness of this data, and so on. So that's why it need to be tackled differently. Yet, this big data represent opportunities because there are challenges in handling this big data storage because of its voluminous, because of its speed, because of variety of data and the reliability of this data. So we have certain technologies that handle this data. One of it is Hadoop. Hadoop is an open source programming environment which was developed by under the Apache Foundation. Yeah, you can check Apache Foundation. There is an Hadoop. And then MapReduce is a programming model where you break up the content of this data, map it, and then you break it into smaller portions so that we can analyze it. So, and then big data, there's another issue pertaining the data. Big data is in terms of data security, protection on the stored data, and then complexity of these 4Vs, and then more companies are searching for these data scientists. We need to have people who are able to handle the big data. And then one of the source of this big data is the Internet of Things. What is Internet of Things? Let me use um, let me change. Let me use a whiteboard. I think I'll use a whiteboard. Okay, I'll use whiteboard. Yeah. Okay. This is on IoT. Yeah. Internet of Things is IoT. Internet of Things comprise of actuators and sensors. They have sensors and actuators. Here we have sensors. Oh, and actuators. Sensor is the one that sense the temperature, sense the lighting, sense whatever movement, and so it's a sense. So it can sense temperature, whatever it is. So it is what it does actually sense the activity surrounding the environment or the vicinity of the IoT. And then, but besides the sensor, we also have the actuator who does things to activate or run certain motors and so on. So this IoT have comprised of sensors and actuators. We have sensors and actuators. And then these sensors will collect data, actuators will do the action, and then you have, this is the IoT. And then there are many IoTs here. So we have IoT, Internet of Things, like Raspberry Pi, like Arduino. There are those IoT. There are many IoTs. And then these IoTs will be linked with each other over to an edge device, what we call it edge device. Edge device collects this data from the various IoT components. Then you can have another edge device here. And then this edge device will be oh no, this is edge device. Yeah. So this edge device will eventually bring the data to a cloud. We call it cloud here. How does the data go to the cloud? Cloud is actually a group of servers connected together that provide cloud services to other users, to many group of users. This cloud will be gathered, will bring data from what we call a fog computing. Yeah, so this data actually will be brought up to the edge computing, to the fog computing, and then move to the cloud computing. So at this cloud computing, it will be captured. It will be captured into what we call a large repository. A large repository. We can call it, so we can have big data, yeah. Okay, this is the relationship. We can see relationship between the IoT to edge computing to fog computing to cloud computing, and then you get access to your big data. Yeah, so Internet of Things is the technology that allows data collected from the various sensors in all types of machines to be sent over the internet, because they're linking up to the edge computing and to the fog computing is via the internet to repositories such as the cloud computing, where it can be stored and analyzed further, so that we have a huge amount of data to be collected and analyzed. So from all this data that we have mentioned earlier, where we have data been collected in many formats, doing descriptive analytics, predictive analytics, and then until we have big data, so we are able to do business analytics. So business analytics, we have we recap from what we covered last class. We are able to do standard reporting. We are able to do data query using SQL and structured query language, and then Sparkle and other query language. We are able to do data visualization like the dashboard. We are able to do descriptive statistic, which is more related towards the centrality of the data and dispersion of this data. And then we will able to do data mining, looking into hidden patterns between the variables of each of these data, so that we can look into the time series of this data, so we can have forecasting, and then we can do predictive modeling once we have determined the right mathematical model relationship between the various uh, variables. So from this mathematical model, we are able to do simulation. From simulation, we can do rule-based models. We can make decision, and then we can analyze our decision analysis, and then we can do optimization to find uh, how to optimize our decision, the best decision that we are about to make. So the complexity of this move from the descriptive analytics move to more complex when we move into predictive analytics, and further complex when we move into prescriptive analytics. Basically, descriptive analytics is about telling you where you are now. Predictive analytics tell you where you are heading, and then prescriptive analytics advise you how to recommend a decision. Yeah, so that is business analytics in practice. So we have predictive and prescriptive analytics, which are referred to as advanced analytics. And then we have descriptive analytics, which are referred to as the descriptive current state analysis, current, what we call it business intelligence. So financial analytics, with financial analytics, you can use these predictive models to forecast financial performance based on the various variable. Remember I mentioned to you that we have this result variable, we have and then in order to arrive to the result variable, we will have our decision variables, and then there are some uncontrollable variables. From these uncontrollable variables and in fluctuations and changing uh, values of the uncontrollable variables, we can forecast the financial performance based on our decision variables. So, and then we will also be able to reach the investment portfolio and projects, construct financial instruments such as derivative, construct optimal portfolio of investment, allocate assets, create optimal capital budgeting plans, and then we can also do simulation. This is for financial analytics. Same goes with human resource analytics. It is a new area application for analytics. So we can use HR analytics to HR function is actually in charge of ensuring that the organization has mix of skill with set necessary to meet its need. So we will be able to use HR analytics to determine what we're supposed to hire based on the highest quality talent, providing environment that retains and achieve this organizational diversity goal. It's also being used in sports. You can, if you watch the movie Moneyball, related to quality of talent. And then marketing analytics, we is one of the fastest growing. We can look into consumer behavior such as the market basket analytics, which we will learn later, and then sentiment analytics. Yeah, you look in sentiment analytics and market basket analytics, which will be useful in marketing analytics. So we will be able to understand the customer behavior, so we can determine what sort of budget and then we need to use, and then the pricing strategy, our pricing strategy, product pricing strategies, and as well as the service pricing strategies. So we can improve forecasting of our demand based on the forecasting, and then we can improve product line management, increase customer satisfaction and loyalty. So this is just some examples of how business analytics works in practice. But for this course, actually, we will be doing it. We will not be so much technical, but we look into the managerial perspective of using this analytics, such as in healthcare analytics, supply chain analytics, analytics for government and non-profits, yeah, and sports analytics. Web analytics, we look into unstructured data, and then we and web analytics. This is the analytics ecosystem. Okay, I'll skip this, and then we'll move into the introductory case. I've uploaded in your WhatsApp, the Excel file for this. Yeah, Catherine is a marketing manager for this organic food superstore. I will upload the file as well in your later on. I will upload it in your LMS. This Excel file, it is an Excel file that is called customers. The Excel file is called customers. The name is customers data. So you will be able to look into the various variables. Basically, when you want to do analytics, yeah, you need to determine variables. What are variables? Variables are things that interest us, things that you are keen into look into, and then things that you can see there would be some relationship between these things or variables to another variables. So you can predict some correlation, you can predict some regression of the variables, and then you can draw some multicollinearity, or you can draw some maybe some simple linear programming chart, non-linear programming chart, or binary programming chart within these variables. So I uploaded the Excel file. You can have a look at the Excel file where you can see the customers data, and then this is not an assignment. Assignment is in your group. Individual assignment is in the quiz at topic 1, but this is you can do yourself self learning, where you look at the Excel file and then you see how this person, Catherine, can use the customer's data to identify the organic food superstore's college-educated millennial customers by looking at the birth date and the education, and then comparing the profiles of female and male college-educated millennial customers pertaining to their preferences and so on. Yeah, so you just have a look at it. And then we will start today in terms of nature of data. What is data? What do you understand about data? Anybody want to give some comment on data? What do you understand about data? Aziz?
Hi.
Yes. Assalamualaikum, Aziz. What do you understand about data, Aziz?
I think like previous class you mentioned is a stream of information
Mm.
that have numerous information that we need to analyze afterwards.
Okay. When you define data, you avoid using the term information, yeah, Aziz?
Yeah,
Uh,
okay, okay.
okay, because data are just collection of facts. It is raw facts. The term is raw facts. It is raw, and then it is meaningless. It doesn't provide any meaning. So it is not information yet. Data are very raw collection facts. They are obtained result of experiences, observation, experiments. It can consist of numbers, words, images. So it is the lowest level of abstraction. So it is not information yet. After you aggregate the data with other data, aggregate data with another data, you will build it into information. Yes, the information is gained from aggregation of data. One of the data that we commonly use today is metadata. Metadata is data about data. Data that describe the data. For example, you have a data, say 45 kilogram, and then you another data that describe this data, that is the weight of the package, for example. So weight of package, so then it provide information. The weight of the package is 45 kilogram. So combination of these two data or aggregation of these two data, you get information. For example, another example of metadata is where you do tagging. Everybody have social media today. You put pictures, images, a car, your own images with your family and so on. And then you tag your friends, you tag your family members. When you tag, the tagging is another data which is we call which call metadata because it refers to another data. Combining this metadata to another data is information. Information is aggregation of data. So data is the source of information because it aggregates data to become information. And then when you aggregate information to another data, to another information with your understanding and experience, it becomes knowledge. Knowledge is the higher level after information, and then above knowledge is something what we call wisdom. So data quality and data integrity is critical to analytics because data are supposed to be facts. Data are collection of facts. It doesn't interpret. There is no interpretation. Interpretation is done at the information level. So in this business analytics class, we will collect data, facts, and then we will cleanse this data, and then we will group them to become information. So we make decision based on information. So in order to be able to analyze or use this data, there are things that we have to look at. One is the reliability of data source. The data source need to be reliable. Whenever you want to use data, you look into the data source first. Is the data source reliable? And then data content. The data content need to be accurate. Are you actually able to access this data? Maybe you have some people's data, maybe staff or population and so on. And then some of them you have data, for example, the date of birth, and some you don't have. So you will not be able to determine because you don't have the accessibility of this data. So data need to be accessible. And then you need to look into the security of data, privacy of data. Data are supposed to be rich, so you can have various format of data, like audio, video, image, and so on, richness of data. And then data need to be consistent. If you use metric, and you use metric all the way, and so on. And then data need to be current, meaning must be current as of today. You cannot use old data and combine with the new data unless you intend to do comparison. Otherwise, it is data which is not current or not timeliness, that is not timely prepared. So it will distort the information. And then we can also look into granularity of data. Data can be very fine, very small component of this data, or data can be very coarse. Meaning, so example, coarse and fine is like you can see about material, for example, furniture, very coarse. And then more fine, you can have, say, different types of furniture like cupboards, chairs, tables, and so on. And then when you go to more finer, you can even have the brand of data with 3 legs data tables and so on. So you need to determine which level of granularity that you want to use for your analysis purposes. And then data need to be valid. So data need to be validated and data must be relevant to the use for your analysis. So these are the metrics for analytics ready data. So how do we prepare our data? Before that, we look into the simple taxonomy of data. There are two kinds of data that we can get. We have structured data, we have unstructured or semi-structured data. Now I tell you about structured data. There are two types of structured data, which are we call, besides this categorical and numerical, besides that, we also have man-made data and machine-generated data. Human-generated data and machine-generated data. Human-generated data are being keyed in by human, and machine-generated data are data being captured by satellite images, by your EEG, ECG, your QR, your whatever data that we captured in your sensors and so on. So those are machine-generated data. And then you have human-generated data. So it falls into both. The unstructured data will have human-generated data and machine-generated data. Same goes with the structured data. You have human-generated data and machine-generated data. And then amongst all this data, human-generated and machine-generated data, there will be structured data. And then this structured data, we can have categorical data and numerical data. Okay, comparing numerical data is things that you can count. It can comprise of intervals, 1, 2, 3, which is an intervals, or ratio data. Ratio data will have a true zero in its value. So we can divide, for example, Celsius, Kelvin, and Fahrenheit. So those are ratio data. Intervals are normal data, but there is no clear zero there. And then categorical data. Categorical data, it can be those without order. We call it nominal data, like male and female. There is no higher than the other, so it's similar. So nominal data. Or ordinal data, we have by age group, by ranking. So for example, like qualification, you have diploma, we have bachelor's, we have master's. So those are ordinal data. So structured data comprise of these two, categorical data and numerical data. Categorical data, we have nominal data and ordinal data. Numerical data, we have interval data and ratio data. And then beside this structured data, we have unstructured data. Same, equivalently important. And then in fact, this unstructured data or semi-structured data comprise of 85% of all the data that we have. This is written by McKinsey in 2012. You look into all this data, you can have access over the internet, and then only 15% are structured, and then the balance 85%, 80 to 85% are unstructured. So when we talk about big data, the concern is about handling this unstructured data, because unstructured data are 85% of all this data. So what are these unstructured data? Which are the textual data in books, in reports, even voices that you say converted into transcripts, yeah, passages of writing. So those are textual data. And then we have multimedia data in images, audio, video, multimedia data, and then data that is being transmitted from machine to machine, something like XML, extensible markup language, data in the format of XML, data in format of JSON, JavaScript object notation. So those are data. So these are basic, simple taxonomy of data. So how do we analyze all this data? So overview, how do you use data? Data are facts and figures, raw facts. I need to add raw there, the raw facts and figures collected, analyzed, and summarized for presentation and interpretation. Another thing that I need to write there is data are meaningless. So data doesn't provide any meaning until it is combined or aggregated, integrated to form information. So when you look into data, there are certain characteristics and quantity of interest that we want to take. For example, we are measuring your height, you're looking into your weight. You put a scale and then you measure your weight. That is the quantity of your interest. If you look into the height of a person, for example, you have a small kid, your children, and then you want to measure the height, the quantity of interest is the height. And then if you look into BMI, body mass index, you will be looking into the component, the aggregate component between the, we call it combi, between the height and as well as the weight divided by height. And then if you look into certain, so what are the components? For example, you look into the profit. So the quantity of interest would be the revenue and as well as the cost of the component. So things that interest us are called variable. Yeah. Variables are characteristics or quantity of interest that they can take very different values, but with this interest that we are interested in. So if people ask you what is variable, variables are figures that we are interested in. So how do we obtain the variables? The values of the variables are obtained through observation. Observation is a set of values that correspond to a set of variables. And then this observation will vary over time or over different groups. So we can say it is a variation. There are variation. Variation is differences in variables measured over the observations. And then we can have random variables, which is not known uncertainty. Yeah, so that is basic meaning of data. So the data can be collected in population. When you do big data, we look into data in population. We can also collect data sample when we have we are not capable to collect the whole population data. So we will collect only a subset of the population and we call them sample. One method of doing sample is random sampling. Besides random sampling, you have stratified sampling and so on. Snowball sampling. You will learn it in your later on. And then data, like I mentioned earlier, will be numerical data or quantitative data and categorical data. And then data can be cross-sectional, meaning that at the same time, but across several entities, we call it cross-sectional, or data could be time series, meaning it's the same group, same entity, but over a period of time. So it can be cross-sectional data, it can be time series data. So data can be collected for experimental study. So one thing when you do experimental study, there must be a variable that is in control, that you can control. Experimental study, that is experimental data, meaning that there is a data, a variable that you can control. And then besides experimental study, you can do observational study where there is no data that you control, no attempt to control any variables. So, and then you need to manage this data. So because the huge volume of data, variety of data compel you to organizations to spend large amount of time and resources to gather, to clean and organize data before performing any analysis. So we call it data wrangling, data wrangling. So when the amount of data grows, the difficulty to do wrangling increase to enable. So it is the reason why, so it is very important to clean and organize big data. So because it will be the prime barrier in organizing, in taking full advantage of business analytics. So what is data wrangling? Data wrangling is the process of retrieving, cleansing, integrating, transforming, and enriching your data to support your analysis. So what is data wrangling? So you retrieve the data. So data will collected from various sources. Remember, the sources must be reliable. And then data need to be cleansed. You need to remove the erroneous data, data which is not consistent, data which is not accurate, and so on. You need to remove them. And then you need to integrate this data because data can come from various sources. You need to integrate them. And then you need to transform this data to a specific format so that you can maintain the consistency because some data can come in metric, some data could be in feet, hundredweight, and so on, the British terms. So you can transform them data, or in some dates, for example, MDD and so on. So you can combine this data, but before be able to integrate, you need to transform this data and then enrich this data so that you can then only you will be able to use it for subsequent analysis. So the objective of this data wrangling is to improve the data quality so that you will be able to reduce the time and effort to perform analytics. So you can do true intelligence in the data. So data management, on the other hand, is involved in the process that the organization uses how to acquire, how to organize, to store, manipulate, and distribute this data. So that is data management, and data wrangling is also part of data management. So what is database? Database is a collection of data logically organized to enable easy retrieval, management, and distribution of this data. So many organizations have adopted a database approach for storing and managing data. So what is database? Database is a collection of data. Most commonly, people use relational database, but besides relational database, there are also non-relational database. Yeah, so the most common type of database people use is relational database. Okay, when you look into data, okay, remember, yeah, so data refers to records, and these records will have fields of this record. In the real world, these records reflect an entity. We have entity like people, building, university, and so on. Those are entities. So these entities are referred to in the database as records. And then these records will have attributes because people have name, their height, their date of birth, and so on. So these are attributes. So attributes is placed in the database as fields. So these are we have row and column. Yeah. So row is the records. In the row, it is the records. The column is the attributes or characteristic of the objects. So there is relationship between one record to another record, one group of record, one group of table. We call it table. One group of table to another table. For example, a table on the lecturer and the course. For example, one lecturer will teach many courses. So this relationship is the one why we call it relational database, because there is relationship between one entity to another entity. So the most common database management system is the RDBMS, Relational Database Management System. And then a database management system is a software application that we use to define, manipulate, and manage data. Example of a relational database management system include Oracle, IBM DB2, SQL Server, MySQL, Microsoft Access. We have many more today. And then so data, in order to understand how data can be extracted, you need to know the structure of data or data model. Yeah, how the data is being designed. So data modeling is the process of defining the structure of a database. So one way of modeling data is using the relational database. Yeah, so first to facilitate the retrieval of this data. So entity relationship diagram is the graphical representation of the data. So it comprises of entity, the instance, and relationship between one entity to another entity, and then we have primary key, composite key, and so on. So let me show you. Okay, this is an example of entity relationship diagram. One customer have many orders, and then many orders have many products. For example, this is a relationship between one entity to another entity. This is why it's called relational database. And then in this customer table, we will have the attributes. The attributes begins with this last name, first name, street name, and city. That is the attributes. And then, but we have a primary key. Primary key is a unique key unique key to refer to an instance of the record. an instance or the record of the attribute of the entity. Yeah. So you can see customer ID is a primary key. Another primary key is the order ID is a primary key. But the customer ID also appear in the order here. So at the bottom, you can see customer ID. Show you the end of the okay, you can see here customer ID. It also here appear here at the order. So this is referred to as the foreign key, a primary key that appears in the different table is called a foreign key. Yeah. Okay. Okay, and then we have a composite primary key here, order ID and the product ID. This is a composite primary key. We combine the foreign key here. So we have in the entity relationship diagram, we have this entity, we have instance. Instance is a single occurrence of this entity. And then entities have relationship with one another, either one-to-one, one-to-many, and many-to-many. And then we have primary key, which is the particular attribute that uniquely identify each instance of the entity. So if the primary key appears in another table, it's called a foreign key. Then we have a composite primary key, which is the primary key that comprise of more than one attributes. So you can see here, so this is a entity relationship diagram. Yeah. And then this is tables to tables. We have different tables here, and then you can see the tables, and then you can see the primary key here. You can see the attributes here or the field. In the real world, the attributes are referred, the real world, we call it attributes, but in the table, we call it fields. So fields are sorted in columns and the records are sorted in row. So it is a two-dimension table. So, and then these dimension tables are linked to one another. We have relationships. So that's why it's called relational database. So data management, so this is data management. So once the data is stored in a relational database, we can retrieve them using database query. The most common popular query language is called structured query language, SQL, structured, yeah, there is a D there, structured query language. So using this structured query language, you can manipulate data. And manipulate data here, meaning that you can add and combine data. And then you can specify the attributes, the tables and criteria of the data, and then you will be able to retrieve them. And retrieval is referred here as querying. And then you can use three keywords, select, from, and where. Select is where you specify the attributes, from, you specify the table, and where you use particular selection criteria and or condition. So this N is something that you can see. I'll use chart here. Let me see. Okay, this is N, this, and then you have this. Okay, and then you have A here, and then you have B here, and then you have C here. So remember this, you call set theory. When you do set theory, you use this. So A and B means A, what is the word? And B is A plus A plus B minus C. Why minus C? Because when you add A plus B, you will do duplicates of the C. So you need to have minus 1C. So A or B is, this is A, this is N. Eh? This is N. If you use O, I don't have the symbol here, but it is the U. It is A U O B is no, this is wrong one. This is the wrong one. I need to clear this. This is A or B is A and A or B. Yeah. A or B is A plus B minus, this is the one that minus C. Yeah. And N is A and B equals C. Yeah, so this is where, this is how do you use your where. Yeah. This is where. Huh? When you use where, you refer to the set theory, then we can have N. Yeah. N or condition. So either N or condition. If it is N, so A and B is the intercept of A and B, which is C. For A or B is the union of, this is called union. This is called intercept. Yeah, union and intercept. Yeah. So, okay, we have this intercept of A and B, which is C, which is in the middle. But if you have or, you refer to union of A and B. So you have to A plus B, and then you have to minus 1C, because when you do union, actually you're combining A and B. So you will double count the B once. Yeah. Okay, any questions so far? Just basic SQL. You'll not be doing SQL anyway, so but this is just basic understanding. And it maybe there will be in some quiz or some assignment, or later on in your assessment, there can be some questions pertaining to this data management. Any questions so far? Okay. Tamizi, Chui Jia Ying, Cuisine, Christine, okay?
Okay,
Tapi-
betul. Okay.
Akmal, okay? Lenaka, okay? Okay, you learn this in school, right? Okay, so now we move on to the next page. Okay, I need to clear this off. Okay, this is how you do in the where is it? Move all this. Okay, this is how you write up your SQL, where you select the customer. Customer refers, when you say customer here, refers to the table. Last name refers to the field in the table, in the customer table. So you are selecting customer table, the field last name, customer table, the field first name, the order table, the field is order ID, the order detail table, the field is quantity. So you from the tables of customer, order detail, and product. These are the four tables you are selecting. So when they do the selection, they will look at the primary key and the foreign key to determine which record it is. From the selection of the particular record, it will pick up the specific what do you call it, the attributes or the fields, where you can have the product table and the product name is written there as organic sweet potato, and the order table and the order the attribute field name is 10/11/2018. So n, this is n, meaning that it is n combined, it is intercepts. Yeah, when you say yeah, n, N is intercepts. If O is union, yeah. So these are the intercepts. So we will be able to select that. So relational database provide business with an efficient, effective way to manage data, but it is not really flexible actually. So we have something what we call it no SQL, not only SQL. Well, we will cover that later, not only SQL. Our so however, different business departments have their own individual and isolated database, so it's difficult to analyze data across department and business unit, and then there could be data redundancy and data inconsistency. So you will have a data warehouse where you put everything into a central repository of data, from where every department within the organization will be able to retrieve this data. So it is more integrated and more accurate. And then it supports managerial decision making because you can retrieve your data from this large data warehouse. And then the data warehouse is organized around subjects such as sales, customers, and products, not by department, it's by subjects. Yeah? And then these subjects are provided by dimensions. We will cover dimensions later. So we have historical and comprehensive view of this entire organization, and then the volume of data can become very, very large quickly. So because this data is non-volatile, we call it non-volatile, meaning that data in your data warehouse cannot be deleted. If you want to change any data, you need to input another data to rectify that data. Yeah. So data must be integrated from the different databases in the different department. We call this process extraction, transformation, and load process. We call it ETL. This the ETL is where you integrate data from the different databases in the central data. So in central data warehouse. So then later on, data can be retrieved, reconciled, and transformed into a consistent format. And then load the final data into the data warehouse. Besides data warehouse, we have something that we call data mart. Data mart is a smaller scale data warehouse, which is a small subset of the enterprise data warehouse. So data mart focus on very specific subject or decision area. So data mart, and then all this data warehouse and data mart will conform to a multi-dimensional data model. We call it, sometimes we call it star schema. And then there's another schema, we call it snowflake schema. So it's specialized in relational database. So data is being sorted in this dimension. And then we have fact tables. So dimension table provide business dimensions such as customer, product, and so on. And then we have fact table. We break it into a smaller dimension. So we have something like this. This is star schema. You can see the dimension there, product category with dimension, customer dimension. From the fact, we have break into dimension. And then you break the dimension further, we have this, oh no, I'll cover that later. The snowflake. Yeah, so this is star schema. We can slice and dice using the different dimensions. Besides this relational database, in order to use for that big data, for example, it's not easy to use relational database. Therefore, people opted to use NoSQL. NoSQL is a non-relational database. So it can handle structured, semi-structured, and so unstructured data. It's more flexible and then scalable. And then usually people will combine it alongside with relational database. Earlier, it's called not only NoSQL, but later on, people, when we cannot avoid using relational database, they change the term to not only SQL. So NoSQL stands for not only SQL. Okay, any questions so far before we move into data inspection? Yeah. So once data has been extracted from the various data warehouse, we put into database, into data warehouse, into data mart. So this data need to be inspected. You review, inspected to make sure that the data quality, and then they make sure that it is relevant for the purpose of information for the subsequent analysis. So you can one step is actually visualize the data. You can count them, you can sort them. So this is the most uh, initial stage of reviewing data is to visualize it, count them, sort them, and then understand and then look into the outliers of this data. So counting and sorting will help us to verify that data is complete and then whether there are missing value, and then sorting data will break it into the range of these variables from the minimum to the maximum, and then whether we can put into a single variable or they can break it into multiple variables. And then then this data will be prepared. So the real world data are dirty, misaligned, overly complex, and inaccurate. So they are not ready for analytics. So you need to do various processes to ready this data. First step is called data pre-processing. Data pre-processing comprise of data consolidation, data cleansing, data transformation, and data reduction. Yeah, so there are 4 steps in the data pre-processing. First is data consolidation, data cleansing, or we call it data cleaning, data transformation, and data reduction. So actually you require experience to develop this. So data consolidation is where you have data from various sources put here. It can come into OLTP, online transaction processing. You can have your legacy database, you can have your web data or other social data, various sources of raw data. You consolidate them by collecting this data, selecting this data, and integrating this data. Remember, these data are raw facts. It doesn't provide any meaning. So you consolidate first, collect this data, select, integrated this data, and then you need to impute the value. You put in the value, reduce the noise, eliminate duplicate. Sometimes you take duplication of data. And then you will transform this data, normalize this data, discretize some data. Some data are continuous, so you need to discretize them into discrete numbers. And then you will create attributes. From this data, you will put them into attributes or the fields. And then you will reduce the dimension. Remember, we talked about Snowflake, just now the star schema. You need to determine the dimension, reduce the dimension. You can combine them, reduce some volume of data, and then you balance this data. So data reduction comprise of, data reduction comprise of dimensional reduction and as well as variable selection. Dimensional reduction, so there can be too many reduction. You can combine certain reduction to reduce it, and or you can select certain variables that interest you. So variables are things that interest us, and then among the variables that you can detect variables that are more relevant for your analysis, you can select the variables. So, and then you can do cases or samples. You can want to do cases study or you want to do sampling. You can select the samples, do sampling, various methods of sampling, random sampling, stratified sampling, and so on, snowflake sampling, several methods of sampling, or you can do stratification sampling, balancing of sampling. For example, you want to study, there are in your data, you have male and female, maybe you can have a balanced number of male and female, or maybe you have different occupation, different social structure, you want to have balance of different social structure, we call them stratification. So once you have inspected and explored data, so you can do data preparation process. First thing that you want to do in your data preparation is to handle missing values, or you can also subset, and then you subset this data. How do you determine missing values? So in your key variables, the variables that you are keen to look at, there might be some missing values, which is of course which is crucial. You need them for your subsequent analysis. So what do you do when you have missing values? Okay, and then at the same time, when some data analysis or most data analysis project just focus on a portion or subset of the data rather than the whole data set. So you need to do subsetting of this data. You maybe say your data will include the large population, the whole population of Malaysia, but you are just looking into, say, Sabah, you're looking into Sarawak, you're just looking into East Malaysia, or you are just looking into a state of Johor, for example. So you need to do subsetting of this data. You can select groups, or you want to compare the two subgroups. So you need to determine which portion of data that you want to analyze. And then, okay, now we begin into missing values. How do you determine, what do you do when you have missing values? Missing values is a common quality problem in data set. Sometimes data is collected by enumerators. Sometimes data are collected by machine. Sometimes the data collected from transaction processing. So you need to determine why your data is missing. So it can lead to significant reduction in terms of number of usable info observation, and then it can produce biased results to your analysis. So you need to determine why you have these missing values, and then understanding the missing value is the first step in treating the missing value. You need to know why missing value happens. Yeah, so it can be human error, sloppy data collection, maybe your enumerator is not doing well, or if there is problem with your machine failure, or human error that purposely did not collect. So you need to understand why the missing value happened. Yeah, that is first thing when you handle missing value. And then next step is, how do you treat the missing value? What do you do? You can omit, meaning that remove the whole record. Yeah, you can either remove the whole record. You can even remove the whole variable if you think the variable is not important, or if it's the record doesn't really affect the whole number, the whole analysis. You can remove the record. Yeah, so you can exclude the observation. Exclude observations meaning that you remove the record, you remove the row, you remove the row. So this, you can use this when the missing amount of missing value is small or concentrated in small number of observation. It doesn't affect. So you can just omit them, and then it doesn't affect. It's that your result will not be skewed or biased. Another method is you impute, meaning that you put in, replace the missing value with some reasonable value. So how do you determine what is the reasonable value that you want to use to input them into the missing value? For numerical value, you can just replace it using mean or average value. So you can look across the observation, you take the average, you put it in. So it will not affect the whole average because it is an average anyway. When you total the rest of the number and then you divide by the number of observation or n, and then you get the average, and then you put the average there, it will not affect the other. This is if there is not so much, it doesn't affect the whole analysis, meaning that the number of missing value is small. So this is easy to implement. It doesn't increase the variability of the data set because it will not create an outlier. It will not create different variance value, will not create your effect, your standard deviation or centrality of data because you're putting a mean value. But if your number of value missing is very huge, number of value missing is huge, you cannot use mean, because if you do mean imputation, it will distort relationship of the variable. So it will lead to biased result. So you can only use mean as an imputation if the missing value is small. Yeah, for advanced method, you can use regression. Yeah, you use a regression, meaning that you have to draw a graph, you calculate the regression, and then from the regression, you place the missing value according to the regression value at that or y or x value. So that is for numerical value. For categorical value, the most frequent category is just put an unknown. So you have no, yeah, just put unknown. So if the variable, yes, like I mentioned earlier, if the variable is not important, is unimportant, variable is not important, you can just put a proxy variable. that does not have the missing value. Or you can also exclude the variable through straight away, you exclude the variable from the analysis. So some analytic techniques, for example, like when you do decision tree, so can be applied even with inclusion of missing value. Yeah. So depends on your analysis. We'll cover your analysis later. After this, decision tree analysis is at your prescriptive analytics. Yeah, that is data preparation. So this is data preparation, and then this is how do you do in Excel. Okay, another important data preparation is treating the outliers, extreme large or extreme small values, which is called as outliers. You treat the outliers. It is not noteworthy that presence of outliers uh, uh, due to the presence of outliers, actually it's preferred to use median, because outliers, and you have outliers, you have two extreme value, two extreme high value to extreme low value. When you use mean, you will distort the value. The mean will be distorted because of outliers. Yeah, so you can just take for example, most of your numbers are just between say 1,000 to 5,000. Suddenly you have 10,000, you have one, for example. So when you average out, your mean will be distorted. That's why in certain, when there is outliers, and then you can determine that outliers is not an error. So it's preferable that you use median to determine the centrality of data, not the median. Use median instead of the mean. Yeah. So because mean will be distorted by outliers. Yes. So the value of mean will be distorted by outliers. So then you can also extract portions of data which is relevant to your analysis. We call it subsetting. Subsetting is is used to pre-process the data prior to analysis. For example, like when you have a time series data, you look into certain observation, and then you don't want to look observation too far. So I want to see for these 5 years, for example, and then you have more than 5 years, maybe 5.5 years. So you can do subsetting, you can group the data, you can handle them separately, you can break them into separate, you can do quarterly, you can do and so on. That is subsetting. Subsetting also can eliminate unwanted data. So when you have missing value, you can also remove the highest to cut off the both tails. You have a normalized curve, can cut both tails at the highest and the lowest value. So we call it subsetting. Yeah. So subsetting involves excluding variables. Instead of just observation, you can also exclude variables. Yeah, remember between variables and observation. Observation is at the row, variables is at the column. Yeah, variables is at the column. Yeah, variable is at the column, and then the observation is at the row. So we have row analysis, we have column analysis. For example, think when you do sentiment analysis, we are looking at column analysis, not row analysis. So you can just remove the row. Yeah, remove the row. But subsetting can also include removing variable where you remove the column. Yeah, so when the column is not relevant to the problem, or the column is redundant information is covered by another column, or that particular column has excessive amount of missing value, you remove that column, meaning that you remove the variable. So subsetting can also be performed as descriptive analysis to reveal insight on certain data. Yeah. So this is subscription. I okay, this is this data just now. Okay, this motivational. And then how do you transfer numerical data? So once you have prepared this data, now we want to transform this data. Transforming data means that you change the format of this data into a data into a other format that is suitable for your analysis. Yeah, you want to do analysis, so there are data that comes into different format, and then you want to change into another format. So one way is you form into bins, those binning of this data. We do this. Yes, we will do the what we call it, uh, look into distributions of this data, and then you will do binning. So data transformation, we have various data transformation, we have numerical data transformation, and we have also categorical data transformation. Remember, just now I mentioned that there are categorical data, and then there are numerical data. So we start with transforming numerical data. Yeah. So data transformation is the process of conversion of one format to or structure to another format or structure. So it is meant to meet the requirement of statistical and data mining techniques. We have various data mining techniques. And then it makes sense to, sometimes it more makes sense to analyze the group rather than the small number or number of the in the bin. So we call it binning. Binning is the process of transforming numerical variable into categorical variable. We change the numerical variable to become categorical variable, so you can analyze them as categories instead of analyze them as numericals. For example, like we have age group. For example, we have a population, say 500 population, 500 people, 512 say people, 512 people. And then this from 512 people, you have a person of age of 1 month, 2 months, 4 months, and then maybe 8 days. And then maybe we have 28 years old, 50 years old, 60 years old, and then too vast category, too broad from, and then from lowest of a few days old and then to maybe 80 99 years old person. So instead of, how do you analyze them, instead of looking into age by the each day or each month or each year, you can break them into categories. You can break into categories that we call them binning. So how do you mean categories? We can categorize them into babies, toddlers, after toddlers, children, what we call it, can say young child, and then you can have teenage, adult, veteran, something like that. So you can break the age. So this each bin may not be at this can be at the same range or at different range size. So you can break. So it's quite called binning. So when you break into bins, you converting the numerical variables into categorical variables so that you can analyze them uh, as categories instead of as numbers. So yeah, it is important that you don't have double counting. To prevent double counting, you must make sure there is no overlapping. So binning can also be effective way to reduce noise in the data, because we can see this observation of the same bin, for example, babies, toddlers, they have the same behavior compared among themselves, so that you can, instead of looking child by child, you can group them into a group of toddlers, a group of babies, for example, a group of young child, you know, and then also so break, you put them into what we call binning bins, categorical bins. So all years of this data will be part of the last bin. So again, we have a very small age, maybe a day or 2 days old baby, or you can have someone who have more than 100 years old. So you can remove the outliers. So say you just want to look into active person, you can just remove the outliers. You can see in the middle. So binning is useful in categorizing observation and meeting categorical data requirement so that you can do data mining analytics such as naive Bayes. Naive Bayes, you can look into probability. We'll cover later probability where you look into naive Bayes in terms of chances of certain incidences in certain categories. So beans usually are created you to have equal intervals, but it did not have to create the intervals. For example, age group have different intervals. Yeah, so you can create beans of equal counts or where individual have the same number of observation. Depends on your situation. Yeah. So this is how you create beans. So this is where you have transforming categorical data into the terms of spending. For example, 0, 250, 1,000, you break it into membership into bronze, silver, gold. Yeah. So data transformation is an important step to bring out information in the data set. So you can say information about babies, information about toddlers, young adults, and so on. So rather than putting them into a different age group, we have very individual age group. So it is another common approach to create new variables. Another common approach to create new variable is to use transformation of another existing variable. For example, like uh, okay, another method of transforming numerical data is, for example, like you use profit. How do you get profit? Profit is calculated from revenue minus cost. So you are not measuring, in order to measure behavior or relationship of profit with, for example, business performance, you cannot measure just the cost alone. You cannot measure just the revenue alone, but you need to measure the profit. Profit is another mathematical transformation, yeah, mathematical transformation where you minus cost of revenue, you get profit. So you create a new variable through mathematical transformation of existing variables. Yeah, so you create. Another method is transform raw data value into percentage. Yeah, rather than putting on by numbers, you look into the total population and then you put them into percentage. And then you can see how many percent does this, how many percent does that way, and so on. You put them into percentage. That is how you transform numerical data. One way of transforming numerical data is by, like I mentioned, by using binning, by creating new variables, and then you can also create values into percentage. And sometimes data on variables such as income, firm size, and house prices are skewed. So it is difficult to detect meaningful data. So you can also use natural logarithm. Remember, we learned logarithm or square root transformation to reduce the data skewness. We use square root, we use logarithm. Yeah, and then another method is when you have calendar data. So you can also transform them into another value, date value in the year, for example, to facilitate transformation of calendar data. Yeah, this is now okay, we have covered category numerical data. You see categorical data. I think we only have a few more minutes left. I think I just cover quickly categorical data before you end. Okay, we can also transform categorical data. Okay, we use names or label to distinguish characteristic from a categorical variables, and then we can use nominal and ordinal. Nominal is male, female, or place of birth, for example, state of birth, yes, Perak, Kelantan, and so on. Or you can have ordinal. Ordinal by age group is an ordinal by ranking, by grades, and so on. So you can break them into ordinal or nominal so that we can transform into categorical data. Yeah, so yeah, sometimes you can transfer categorical data into numerical format so that you can use analysis. Yeah, so yeah, so okay, I think we have just a few minutes. I'll cover this later. Yeah, continue with this later. Otherwise, it will be, if I rush, might not understand clearly. Okay, we have covered transforming of numerical data. I think I better continue this transformation of categorical data next week. Anyway, I've uploaded these notes for you to go through. You can read the notes, and then if there is anything that you're not clear, you can ask me. By the way, I put up this show to you. In your learning activity, you have topic 1. Let me show you. I open up the portal. In your learning activity, in topic 1, there is a quiz that you are supposed to do, but you can submit it on November, 5th of November. Let's see. It is in self-learning activity. In your self-learning activity, okay, you can. This is posted. Okay. Okay, you send to me. You upload here. Let me share. You can just upload here. This is an activity, a quiz activity. It's actually activity that you do. Okay. Okay, there is a question here. There is an article here. Provided article, you can download this article. You can read it online, read the article, and then answer the following questions, and then you upload. The due date is 5th of November. 5%. There is a total. I will only give you 2 quizzes. Total 10%, 5% and 5%. You can share, you can discuss. Actually, this self-learning activity, you can discuss with your friends. You're supposed to discuss. Yeah, then I'll change here. You can discuss, and then you can discuss with your friends. Yeah, you can discuss, and then you put it into just a short comment. 1 pager, you upload it here. 1 pager, 2 pages on is okay. Yeah, you can discuss. It's not like individual assignment or group assignment. Group assignment, of course, you do in group. Individual assignment is you do on your own. But this quiz, you can discuss with anyone, any group members, and then it is actually a self-learning, but you gain 10% from your self-learning. Okay, any question? Anything that you are not clear for today's class? Alice, okay, Alice? Alice is IT, right? You're in from IT background, right?
Yes, bro, from IT background, bro.
So it is easy for you.
No lah. I from IT background, but I didn't do it for years already. So
Okay, yes. Okay, you need to do revision, some revision.
yeah, I moved over to sale already. So yeah,
Okay,
some revision needed.
you need revision. Okay, those from IT background, it will be easy. But anyway, I think a lot of us actually went into another areas. And then those coming from statistics, I think it will be also easy. From mathematics, field, engineering, it's not difficult. But any questions so far? Lenaka, Alif, Haziq, okay?
So far, okay.
Okay, it's okay. So thank you very much. I will your group assignment. I owe you a group assignment because as I explained, it's the same thing you need to do. I only have to build a rubric. a rubric, what is expected in your group assignment. And then, but your individual assignment is already there. And then your quiz is already there. Okay, see you again next week. Assalamualaikum and good evening.
Thank you, Prof.
Thank you.
Thanks, Prof.
Thank you, bro.
Thank you, Prof. Thank you, Prof. Yes.